afternoon, everyone. Good afternoon. It's my pleasure today to host this fifth session of AppFest, and we will venture more in the persistent layer of your application this week with hybrid transactional and analytical processing on Azure. Before that, a last reminder on our challenge. Tomorrow is the last day to complete your skilling challenge and get a chance to win a Surface tablet or one of the mentoring session with one of the senior executive at Microsoft. So please, by all means, do follow that links, share your skilling, and you will win that device. Thanks. As mentioned, it's a fifth session of a series of 6. Next week, we will venture in security. And if for any reason you missed one of the previous sessions, don't worry, the recording will be available in the thank you notes, thank you email you will receive after this session. Right, so you will be able to catch up on all the sessions. Before we proceed, a few housekeeping rules. The session is recorded. However, you are not entitled to share this content by yourself, right? Second thing is regarding the Q&A. We will attend them at the end. There's a time at the end. So please ask your question at any time and we will answer them at the very end. Without further ado, it's my pleasure to introduce Andrea, who is my direct peer as architect managers in Singapore, especially for data and AI workload. Right? Thank you, Andrea. Thanks for joining. The floor is yours.
Thank you, Francois, and thank you everyone on the call. So, from the title of this presentation, Transactional and Analytical Processing, we are basically referring to a set of fundamentally database technologies, right, to store, transform, and query the data. So before we actually zoom into exactly what do we mean by HTAP, maybe let me take a moment to explain why we are thinking of introducing then a data and especially a data analytics topic in an event like this that is dedicated to application development and application developers. And the answer maybe is a little bit obvious in the sense that every application that is built and we have elaborated in the previous sessions of this series a set of capabilities that we have on Azure to build and host and maintain those applications, right? All of those applications and business applications have supporting databases that they use most of the time, right, to store the data. Now, the scenario that we want to address is bridging the gap between those operational databases that can be relational or non-relational databases. Bridge the gap when we have in an organization a set of requirements. They want to gather insights from the data that is accumulated and stored in those databases. The insights can be due to they can be extracted by advanced analytics through machine learning algorithms and so on. Now, what happens is when we have such scenarios, we typically have to build data pipelines to extract the data out of the operational databases of our applications and store this data into some sort of centralized place, which we can call an analytics destination. Typically is a database, like it could be a data warehouse or a data mart, but basically a database technology that is optimized to run analytics workloads. So if the operational databases are mainly meant to support OLTP type of workloads, an analytics destination supports an all-up workload more efficiently, especially when we need to run massive aggregations across large volume of data sets. Right? The typical example is an online shop that captures, so the backend of that online service capture the orders, and then at some point in time we have a requirement to support an aggregation of the sales orders to see how much sales we are having on a quarterly basis, or maybe run some machine learning pipeline that can help us predict some future sales. But in order to build those data pipelines that move the data from those databases into an analytics destination, well, building the data pipelines is quite an expensive process. You need to go through an extra transformation and loading of the data. There is a schema adaptation, a number of things. The data can become, there can be streaming in real time, so there can be the data streams, or maybe the data is extracted in batches, so different velocity to the data, right? So building these data pipelines and understanding what the data model could be for that analytics destination is a very complex and very time-consuming task. With a hybrid transactional and analytical processing in Azure, the aim is to simplify as much as possible and basically remove the pain of having to build those complex data pipelines when moving from an operational database into a destination like Azure Synapse Analytics, which is an analytics destination, right? So the idea is to basically not to have you to write or develop expensive ETL processes. We try to build for convergence. Convergence meaning that we try to access as much as possible the data where the data is. At the same time, being able to access and run analytics on the data in a near real-time way. So as soon as the data basically is available in an operational database, how can those data points be made available to our queries in the analytics destination like Azure Synapse Analytics? Now, there are multiple ways to go about it. Today, I want to talk to you about one particular approach, which is called Azure Synapse Link. So the as it was also in the description of this session of today, there are some pre-requirements, and so there is some assumption that you already know an operational database, a NoSQL database like Cosmos DB. And the reason for assuming that is because it is an AppFest event dedicated to application engineers beside data engineers of today. And so Cosmos DB is a good serving layer for web and mobile application, and NoSQL database. So I'm going to assume that you know Cosmos DB well, and I'm going to assume that you have a basic understanding at least of what Synapse Analytics has to offer. If you do not have such knowledge, I will give some hints during the presentation as I go through. But then again, feel free to contact me. I'll leave you my contacts at the end of the presentation so that we can take the discussions forward. Right. So when now we look at Azure Synapse Link, we have built this technology to basically make the data available into Synapse Analytics. This technology is available for Cosmos DB, which is what I will take as an example and elaborate it further. Coming soon will be available on SQL Server and Azure SQL as well, and is already available for Dataverse. So if you integrate applications like, for example, Dynamics 365 and Microsoft Dataverse in general, so the business applications make the data available to Synapse Analytics through the same technology. Just before I introduce more details around the Synapse Analytics, a little bit of for those of you on the lines that have more of a data engineering and a data analytics background, just a quick observation on how this HTAP fit into some architectural patterns that you are well aware of, right? And these architectural patterns, just to have a very super high level view of them, starts with what was invented in the late 80s, data warehouses. So basically databases optimized for analytics. That could be structures, data warehouse, and then ancillary data marts eventually. World evolved in late 2000s. So we introduced, or the industry introduced, the concepts of a data lake to facilitate or to overcome certain limitations of data warehousing. So you were dumping data into a data lake. It was easier to ingest the data, and then you would have a massive amount of storage and compute tools that could analyze the data. We further evolved this pattern into a more comprehensive, I would say, cloud data platform that would provide different capabilities around batch-based processing and real-time processing. So we would rely on the same concept of the data lake, and be separating compute from storage, and then we would have a data lake where you would dump the data in, a set of big data compute tools to transform this data, and then basically load the curated data sets into a data warehouse. This platform would also cater for real-time streaming data. And this would be a good combination to implement a number of analytics and advanced analytics and machine learning use cases onto the cloud. Recently, the industry is evolving this concept one step further, having introduced the concept of the data lakehouse, which is a kind of, let's see, as an evolution of the data lake, where now the data that is ingested and processed into a data lake can be not only processed, but also queried through one common set of big data compute tools. So eliminating a few moving parts and also taking care of the real-time processing within the same platform without additional tools. Now, if I just, from this very 30,000 feet level of these architectural patterns in the analytics world, one observation and one common pattern that has driven the development of the analytics systems is that I think the industry has been pursuing basically the holy grail, so to speak, of performing analytics, minimizing, you see, as you move towards the right, minimizing the data ingestion complexity, trying to avoid data copy, unifying the processing engines for data transformation and querying. And this is, in a way, the HTAP technology and Azure Synapse Link that we are introducing. The feature is available since a couple of years, but I'm introducing it in this session, as well as I'm giving some updates on the recent features on it. HTAP is goes along this pattern of making the technology for analytics as frictionless as possible, right? With specific regard to Synapse Analytics. Now let's go back to our original scenario, where we had a Cosmos DB. We said we would introduce Cosmos DB. Cosmos DB is the backend of our mobile applications, of web applications, being a NoSQL database. Let's say that we have an application that uses Cosmos DB. How do we run analytics on the data? So all type of workloads on the data store in there. Before Synapse Link, you basically had a couple of options. The first one would be to run OLTP and OLAP workloads on the same database. But this was having a performance impact because the two workloads are competing for the same number of resources. And so your latency increase, your cost increase, especially so when the data volumes grow. The second option would be to separate OLTP and OLAP workload. So we use Cosmos DB for OLTP. The data would be exported into a data lake, and then basically through, say, Synapse or other technology, you could query this data lake and then have a serving layer. But this leads to complex ETL jobs. So you have a number of complexity related to the data formats, the ETL jobs, a different storage layer. And then also there's a delay, right, from the data that you are ingesting up to when you can actually derive insights and reports out of the data due to the pipelines. So Azure Synapse Links wants to help you get rid of this complexity when you want to do, again, analytics on top of transactional data. So let's take now the example of Cosmos. Here you have your regular Cosmos DB container. Okay, it is row-oriented, meaning that each document that you store in Cosmos is represented as a row in a data file. Okay, we do with HTAP, so Synapse Link, we transparently for you introduce an analytical store. Okay, the analytical store is basically another storage layer which is optimized for analytical queries because the data is stored in a columnar format, and there's a sync process under the scenes, and I will elaborate on this later, that is basically able to replicate the data transparently for you, the data from the transactional store into the analytical store. Once the data is in the analytical store, if you deploy Synapse Analytics, you can basically leverage a couple of compute that comes with Synapse Analytics, which are either SQL serverless or Spark under Synapse. And through this compute and through a cloud-native HTAP connector, you will basically be able to run jobs or SQL queries and T-SQL that can query the analytical store. And this enables you, because of Synapse Analytics, Spark, SQL serverless, it enables you to run use cases around machine learning, big data analytics, of course, BI dashboards, and data engineering as well. In fact, you can read the data from the analytical store and run Spark jobs that, for example, transform the data in whatever ways are needed to support a particular requirement, and then store the data into a totally different destination as well. So, for example, you can store it in tables within Synapse, so you can store it as external tables on Azure Data Lakes, for example. Now, the beauty of all this, and again, especially if you, I'm assuming here that you know Cosmos, is that there is no RU penalty, basically. So the performance are completely independent between the transactional store and the analytical store. The autosync does not compete with the OLTP workload that is running, so read and write of the web application that is running on the transactional store. Second advantage is that the data stored in the analytical store is compressed. It is cheaper. It's compressed because the column is a columnar format. It's also cheaper because it basically has 10%, this storage has 10% of the cost of the transactional store. And basically that makes the pricing equivalent to blob storage, basically. And this also can be a way to, for example, archive data. It don't necessarily need to support the analytics scenario. It could be seen as a way to archive data in Cosmos in this analytical store. You have a TTL that you can set on the row store and the independent TTL that you can set on the analytical store. So you could have a shorter TTL for the row store and a longer one for the analytical store that basically become like some sort of archive for your data at a cheaper cost than the row store. Okay, again, when you query the data in the analytical store, there are no RUs as such on from a Cosmos perspective. You, of course, are going to be charged based on the Synapse compute, for sure. But that is a compute that is on demand. It can be paused, resumed, and so on. And you're going to pay as well for the data operations that you run on the analytical store. So the reads especially, right? But if you go to the Cosmos DB pricing calculator, you can run an exercise and you will see that it is much cheaper and much also better from a performance perspective to query the analytical store versus going back and query the transactional store through the Cosmos SDK or the Cosmos REST APIs. A few more words around the analytical store. Before I would like to show you a demo of how all this works. But basically, the idea is, okay, let's zoom a little bit. So there is an auto-sync job we said that moves the data from the transactional store and the analytical store that is spin up for you behind the scenes. Is said to be near real time. Near real time because there is an SLO basically of replicating the data as soon as it's available in the row store every 2 minutes, within 2 minutes in the column store. Sometimes when you have slow data ingestion, actually it can take up to 4 or 5 minutes because we try to buffer and therefore reduce the fragmentation of the data files that we create in the analytical store. So we wait for more data before storing it in the column store. But otherwise, for a typical ingestion scenario within Cosmos, is within 2 minutes the data is available into the column store. The column store and all the processes that are needed to go and create those data files, which by the way support all the updates and deletes right in the column store. So it's a complete replica for the transactional store. All the underlying jobs and compute and storage is completely self-managed and there is no downtime. As I elaborated earlier, there is no performance or cost impact on your transactional workloads. We can talk a little bit more, maybe before jumping into the demo, about the schema inference, because now we have a NoSQL database in the row store, and so is a semi-structured format. But you have to transition to a very well structured format, like what are the Parquet files, is what we use in the column store. So I'll elaborate a little bit how that schema inference is done, but it's done automatically, and you have some choices. And okay, there is native integration, as I said, with Synapse to analyze data directly with SQL or Spark runtimes. This is important. This Cosmos DB data is available for analytics in the global region where Cosmos DB is replicated. So Cosmos DB is can be configured as a geographically distributed database for the data to be where the end users are. And so in every region where eventually you replicate Cosmos data, an analytics store is made available so that the row store in that region syncs to the column store in that same region. Okay, said this, I would like to show you a demo, but before I do that, I just spoke a little bit about the schema inference. So let me spend 2 words on this. Recently, we have GA the ability to do full fidelity schema for SQL API. So the default option is well-defined schema for SQL API and full fidelity schema for the MongoDB API. Again, I'm assuming that you know Cosmos. For those that do not, Cosmos is a NoSQL database that can expose itself with different APIs to store and retrieve the data. So the 2 main popular ones, other formats as well, are SQL and MongoDB. So well-defined and full fidelity, we now support full fidelity also for the SQL API. and I'll tell you what full fidelity is in a minute. It's not available yet as an option on the portal. You activate that through PowerShell or Azure CLI. So what does full fidelity means? Full fidelity means, so you are in the raw store, right? You have your document store with a number of properties, and now you are exporting them. Basically, you are syncing them to this analytical store. So there must be a mapping. Well, the full fidelity basically creates one column for each data type of a property in a document. I'll have an example to let you visualize that. So that's when you want to retrieve a property that may have different data types, you have more flexibility. There's a little bit of a coding. You can see the full fidelity syntax to select a status property in a document can be when there are documents that represent the status as a string or as an integer, you can actually use a dot notation to access that property as the data type that you need. All right, so for example, this exemplifies what I was saying. Let's say that you have a couple of documents in your raw store in Cosmos with two properties, ID and status. Now the first document represents status as an integer, the second document as a string, right? So if you use a well-defined schema, which is the default option for the SQL API, when you do the automatic schema inference, the string status is not represented because it was the first time that that property was met by sync job that determined the data type for the status. So status in this example was determined to be an integer. In full fidelity, you don't lose the data. All of the data is available. The job recognizes that the status can be represented both as a string or as an integer in the two different documents. And so it will end up in this case with 3 columns representing all of the data that you have in the documents. And that's why it was important, and it was a common request to support full fidelity schema for SQL API. But now I spoke a little bit at length about it. Maybe let me show you a little bit of the demo. By the way, this demo together with other samples we have made them available in GitHub, and this below over here is the link to those samples. The idea here is that for this demo is that we have populated a Cosmos DB database, right? In this case, it's been populated through Synapse, but it doesn't need to be so, right? It could be populated by a backend or some sort of web app or mobile app that is utilizing Cosmos. And we are simulating that we store certain orders of Microsoft Surface at the store. So is a sales scenario, right? What do we do is, and what we want to demonstrate is how we can basically enable this analytical store within that Cosmos DB. So all of our documents are in the raw store. We want to bring them over to the analytical store. And then how we can make use of Azure Synapse Analytics, and in particular the Spark runtime we will use for this demo to go query the column store and then run complex analytics, in this case utilizing basically machine learning to run forecasting and so determine how many items we need to keep in stock at a certain store, right? But the idea here is to show how seamless it is, Azure Synapse Link. So let me just for a minute share my screen over here to allow me to bring the browser up. All right, so I am in the Azure portal. It's a resource group that has been created for this demo. And I have all my services here. There is a Cosmos DB. There is a Synapse Analytics. There's also an Azure ML workspace. In a way, I wanted to demonstrate also the machine learning workspace as part of this because in in a previous episode of the AppFest, we have also introduced machine learning and MLOps in particular. So it's a way for all those of you that have followed each episode in the series to somehow connect the dots, right, and visualize how all these services are tied together. Okay, so in Cosmos DB is quite straightforward. We have our application, we assume, is populated already a number of items. So we have products, retail sales, store demographics. These are our containers. And all the processes that ingested this data over here basically are the OLTP workloads that read and write, especially into the raw store. In Cosmos, you have an option called Azure Synapse Link that you need to basically enable. So by default is disabled. You need to enable. This is a SQL API account, and therefore, because I've done it through the portal, we have a well-defined schema inference versus a full fidelity one, right? I should have eventually enabled that through the PowerShell or Azure CLI. Enabling the Synapse link per se will not bring you any cost. It's only when you basically register your containers, so your data sets, with the Analytical Store, and therefore you start the auto sync job, that there are the cost implication for storage, again, compressed storage in the Analytical Store that we have seen before. So anyway, this is Cosmos. Okay, now if we go into Synapse, so we have Cosmos, we have enabled the Synapse link. This data can be made effortlessly available to the Spark runtime, in this case, under Synapse Analytics. So again, for those of you that are not very familiar maybe with Synapse Analytics, it's a platform in the first place that allow you to spin different runtimes. Those runtimes could be a SQL engine optimized for OLAP. So it's a data warehouse, can behave as a data warehouse, can query both internal and external tables, so managed and external tables. And then you have you can also spin up Spark pools, as well as now a number of other engines, including Data Explorer. We'll leave that for another topic, for another time. In this case, we are pretending that we are leveraging Spark runtime, right? So what we can do in Spark is, well, in the first place, without us having to worry about any data movement, data is now already synchronized in the Analytical Store within 2 minutes, right? So we can just run SQL, Spark SQL, to go and create tables and basically load data into those tables. And so, okay, there was a preliminary step over here, which was to configure Cosmos DB as a linked service, and that would basically allow Synapse to use the cloud native HTAP connector. And said this, we just go and develop our Spark jobs, and so they refer to the linked service that we have. And look at the syntax over here. So we create table, and we create a Spark table using cosmos.olap. So we are connecting to the Analytical Store. There's a way also to go into the raw store, of course. Also, we are going to the Analytical Store, and that's about it. And once we have that, right, we can run our Spark queries. And the most beautiful things is you can now run, okay, all your Spark SQL here capabilities, but if this was a SQL serverless, and very soon we will also support the SQL dedicated pools, the provision pools as well. You can basically run all of your T-SQLs, joins, aggregation across Cosmos containers, which is not natively supporting Cosmos. So you can now do this. You can also get the data from Cosmos as well as data from other data sources, and so join across and run your transformation across the multiple data sources. And imagine if Cosmos was a MongoDB exposed as a MongoDB API, so now you can run basically T-SQL on top of Mongo documents. So it's really an enormous amount of flexibility that you get. In this case here, the query is very simple. We load the data, and then you see we just display the data. So we have actually connected to that analytical store, right? And then we can display the data. And then here there is a boilerplate code. Again, you can find all this code in the Synapse Analytics samples link that was indicated earlier. And the nice thing is that the data that we loaded into the Spark table can be loaded into Pandas data frames, and then we make use, in this case, we make use of the machine learning, Azure Machine Learning SDK to basically take this data, split it into a train and test data sets, and use AutoML in this case to determine, I've already run all these jobs, to determine what is the best algorithm to make a prediction of how many items, based on, say, on historical sales, how many items of a given product I need to keep on stock. Right, and so this determines the algorithm and then runs some testing. This is a whole notebook that shows how accurate is the algorithm that has been chosen. And because from within here, so we are in Synapse using the Spark runtime, we are using the Microsoft Machine Learning SDK and the AutoML SDK, then automatically these experiments, so these machine learning pipelines that we are running here are automatically made available into a machine learning workspace that I had pre-created, right? And so what we can see is that the experiment ran, so there was the Cosmos data, went automatically into the Analytical Store. We didn't have to do any particular thing about it. We were managed to read that from Spark SQL, and from there we ran a ML experiment and AutoML, and that AutoML return that run was stored inside our machine learning workspace, all within Azure, and without much configuration at all. And this tells us that the algorithm that was selected was a voting ensemble, and there was a certain margin of error in the predictions and so on. And then here we can plug in all the features of the machine learning. We have spoken about it in the previous AppFest last year. MLOps can come into play in all this. It's something that we have spoken a couple of episodes ago in the AppFest. So this is the demo that the quick demo that I had for you today, just to help to visualize how these technologies can be enabled and how they play together. Maybe a few considerations now. Well, one thing that currently you can't do within Synapse Analytics, and this requires that you understand the difference between Spark and SQL serverless within Synapse Analytics. But basically, you cannot query Spark tables using SQL serverless, and the other way around, you cannot access views that you create in SQL serverless with Spark, at least not at the moment. So you would kind of have to choose one or the other, but you can combine, the various jobs that you need to run depending on what your use cases are. For example, you can use the Spark jobs, okay, or you can use create external table as select CTAS, T-SQL in SQL serverless to read and transform your data the way you want, and then aggregate that into Azure Data Lake. And then once you have that, right, because you can always export the data into another serving layer, right? So in this case, maybe you can run your transformations the way you like, store it into Azure Data Lake, whatever format is needed. And then again, let's say that you had used the Spark for that. You can use a SQL, Synapse SQL to go and query the data. And then therefore, if I had written a Spark table into that Azure Data Lake, now I can access that using SQL serverless, right? So we have added that one level of indirection to solve the problem. And this also and make me do another consideration that I wanted to portray. I mean, the destination of these aggregations and transformations does not necessarily need to be also an Azure Data Lake. It can be a Cosmos, another Cosmos DB raw store, for instance. So let's say that I'm reading the sales data, and then through Spark, I'm running that machine learning that allow me to derive certain insights, right, and do my forecasting. Those forecasting can be, or maybe say recommendations, for example. Those recommendations, those predictions can then be made available back into Cosmos DB so that a mobile application or a web application at the point in time in which a customer is interacting with that app can show back what as maybe a set of products that are being recommended. So you can do this because the path all the way from Cosmos into the Analytical Store back into Cosmos is basically a near real-time path, right? So this is one consideration. Okay, like this example, here are a few other example architecture typical scenarios that our customers have solved utilizing this technology. We have use cases around supply chain analytics for forecasting and reporting. So typically here you have batch-based data coming in as well as online data and therefore streaming data. And Cosmos DB could be a good database engine to support the ingestion of the data, especially if you have high IOPS or high write throughput, so a lot of transactions are going on online, or if you have a geographically distributed requirements such that the online shoppers in this case can be accessing the web app in different parts of the world. So you need to have a database that sits close to them for write and read. So the data is coming in, let's say at high velocity. It goes into the transactional store. Through the autosync job, we basically go into the analytical store, and then again, if we have reporting requirements, we could access that analytical store in place, basically using SQL serverless to run T-SQL and therefore support maybe operational dashboards through Power BI. So Power BI accesses Synapse SQL serverless, pushing down the queries goes to the analytical store. Or what I was showing in the demo earlier, you may have forecasting type of scenarios where you may want to use machine learning, and this is what we demonstrated earlier, using, for example, things like Synapse Spark, reading the data, deriving the insight using ML, and then basically storing the insights or the predictions or the forecast in this case back into Cosmos DB so that the data can be read out and served again to the web or mobile app that we are supporting. Real-time personalization is another typical scenario. Here you can see you have a web app, is an e-commerce store, and basically through the backend with these other processing APIs that's represented on the bottom here. You have a backend that basically writes to the transactional store, again, auto sync into the analytical store, just enabling by configuration. And then you can have a Synapse Analytics with either SQL or Spark runtimes, doing some processing and maybe coming up in this case real-time personalization with certain recommendations based on the orders that are that came in from a particular customer. And so those recommendations then they can be stored back in Cosmos, because you can have another microservice powered by AKS, the Kubernetes Service Recommendation API, that is able to serve those recommendations back to the web app. Some new features, because so some of you may have already seen Azure Synapse Link for Cosmos DB before. As I said, coming soon, there will be a Synapse Link also for Azure SQL. And meanwhile, even for Cosmos, the features keep expanding. So what we have added is custom partitioning, right? So one of the requests that we had earlier on is, okay, so if I have my transactional store, then the data is replicated into this analytical store, fine. But there is no particular, because everything is automatic, right? So there's no particular partitioning scheme for the analytical store. The data in the analytical store is partitioned at the moment of arrival, right, as it is ingested in the columnar store. So then what we have introduced is you can now write specialized Spark jobs powered by Synapse that can read from the analytical store and then basically utilize a different key, partition key, or even multiple partition keys, right? And write the data into a partition store. So this is another store, right? So you have the transaction store and the analytical store, and then now you have a partitioned store. And you can use multiple keys, right? Because the way you would use your partition key for the partition store is based on an analysis of what would be your access patterns or your analytical query patterns, right? So you optimize based on that, because what you want to do is to basically achieve what we call as a partition pruning, skip the data so that your queries do not need, basically filter it and therefore scan less data, which improves the performances, and it also lowers the cost, because every time you, for example, if you use Synapse SQL, serverless SQL, you are charged based on the amount of data that you scan. So faster query execution, lower cost. But now you could have multiple queries that you need to optimize for, right? So you may have, there was this example, for example, for a customer we were doing for connected vehicles. So basically, it's an IoT SaaS provider solution. So there are a number of IoT devices that are collecting data per tenant, because it's a SaaS solution. So the queries, so when the tenants wanted to query their data, of course they wanted to query their own data set only, and so there should have been a couple of keys. The tenant to look only at the data that we need, as well as dates to so there was a time dimension. So you can do that. You can indicate the multiple partition keys. You can also have multiple partition stores. So yes, you can have multiple keys that handle a certain set of queries, but then you may have other queries that need other type of keys, and so you could also through these jobs run deploy, different partition stores. Okay, yeah. Yeah, there are some limitations as well with custom partitioning, though. So as you see here, actually is the runtime that can be used at the moment in Synapse to write those jobs is Spark. So Synapse SQL Serverless is not supported yet. And we only support the Cosmos DB SQL API, not the MongoDB API yet, but it's on the roadmap. And custom partitioning, as I was saying, is it's quite flexible. So there's a link again over here where you can read more about it. Especially you can see examples of how to write those Spark jobs. But here is what the points that I would like to make is that these Spark jobs are completely customer managed. So you can schedule the frequency by which you basically run this job to take the data out of the analytical store and basically write it into the partition store, right? And you have flexibility in where to store the partition store in ADLS. So when you deploy a Synapse workspace, the Synapse workspace gets associated to a storage account. So you can choose a path within that storage account. And so that's why you could have multiple paths corresponding to multiple partition stores. So you have multiple jobs and multiple partition stores. You have flexibility in terms of partition keys. And yeah, that's about it, right? So this is something particularly new. So before maybe leaving ourselves a few minutes for Q&A, a few key takeaways that to conclude and you know, the presentation of today. Again, the first thing is that yeah, there was in a way data movement, but it was completely managed, and so no data movement, meaning that you can now starting from an operational database, you can basically address analytics workloads without having to develop complex ETL and data processing pipelines. So in that sense, there is no data movement. And now the auto-sync job basically takes care in a fully managed way of that aspect for you. The type of scenarios that we are trying to handle with this is basically enable analytics with a one-click experience and get a business in complete view, meaning in control of the insights that they can extract out of the data because of now this transparent way of enabling analytics. This technology is well suited to support the near real-time BI reporting because if you have sync jobs within 2 minutes from the moment in which a document is stored in the raw store of Cosmos DB, that is basically within 2 minutes it's replicated to Analytical Store, and therefore you can report through, for example, Synapse SQL Serverless, connect that to a Power BI reporting. And so basically you have near real-time insights. And basically the idea is that you accelerate time to insight, and is a solution that try to make the try to bridge an OLTP and OLAP workloads in a supported way, so future-proof in the most frictionless way. So these are the key points that maybe the key takeaway for today. Now, said this, let me know, maybe Francois, with your help, I'm not sure I can see the Q&A panel. Oh, now I realized that you were stuck on the browser.
Yes, if you can switch back.
Oh, okay. I went through. Okay, let me. I did a lot of talking, and okay. So let me switch back. I'll quickly run through the slides and we have time for the Q&A. So sorry guys about that, but the slides that I wanted to present after the demo, basically, I came here when I spoke about the different destinations and how you can combine basically Synapse SQL serverless jobs and Synapse Spark jobs, because currently you cannot query Spark tables using SQL serverless or access the SQL serverless views with Spark, but you can use one or the other to export the data into an Azure data lake and then query. So maybe using Spark and then export a table and then query that with Synapse SQL, as well as you can export back to Cosmos itself. So I was saying Cosmos is also a serving layer and a couple of reference architecture. That is what I discussed. And then here is where I was talking about the custom partitioning preview, where now you have the transactional store, the analytical store, and the partitioning store. The limitations I talked about, and you know, all the flexibility that you get with custom partitioning, and these were the key takeaways. Now, I guess there may be a few questions since the slides were not immediately visible to you. So let me know if there are questions.
Sorry, there was a few questions around Synapse and connection between Synapse and Cosmos DB. Don't know whether the audience has more questions around that. And yeah, analytical store, two links. Trying to paste all the links as well so that the audience you can follow up after that if you have additional questions.
All right. And
yes, exactly.
Yes. Yes, please feel free to contact me or Francois as well. These are our links. Right.
Yeah. And if you can go to the next slide, exactly, we would like to hear your feedback. This is so important for us to constantly improve the quality of contents and the way we deliver the content as well. So looking forward to get your honest feedback on that. Thank you very much, everyone, for joining today's session. I mean, there was a lot of content to digest. Hope it answered all your questions. Thank you.
Thank you.